All right, here we go, section 5.5. So now that we've seen like how a logarithm actually works, now let's look at the properties that they have and go from there. Okay, so first property, and these are kind of interesting too, and they are a little weird at first, but if you have log base a of m plus log base a of m, or n, so the bases are exactly the same and you're adding them together, you can convert that into log base a of m n. You can actually take what's inside the logarithms and multiply them together. Now, if you subtracted instead of added, what do you think that would change in here? And hopefully everybody said that turns it into division, and that is correct. It'd be m over n. So how do you tell which one's in the numerator and which one's underneath? Well, whichever log was positive, that's the one on top. Whichever one had the negative, that's what goes underneath. So addition turns into multiplication, and subtraction turns into division. The book goes through a little proof of that, so if you want to flip through the section and look at the proof or even Google it, you're more than welcome to. As for the sake of time, we're not going to go over it. You can just take it as a given. Okay, property number, well, that should be property number 3. If you have log base a of b to the c, so there's an exponent, you can pull that exponent down. So c log of base a of b. Property number 4, log base a of 1, we discussed in the previous section, that's always going to be 0. Property number 5, log base a of a to the c. When the base number matches the big number here, they're the same. Everything cancels out and you're left with just the exponent, because in this case it's like the exponential function's been plugged inside the logarithm, so a function and its inverse cancel each other out. And the same would be true if it's in this way. If the logarithm is the exponent of the exponential, again, they're inverses that cancel out, and you're left with whatever number is inside the log. All right, and then the last property, property number 7, is when you have to do a change of base. Now, this is useful when you have like multiple bases running around, or like if you're in chemistry, or in another class where you've got a logarithm and you have to use a calculator. Your calculator can usually only do log base 10 or the ln. If it's of any other base, it's not going to do it. So you can kind of force it to calculate it out. So if you want to change the base, it's going to be log of m over log of a. And so you can switch it to both base 10. Technically, you can switch it to any base you want, but usually if you're trying to calculate it, the calculator has a log base 10 button. Or if you wanted, you didn't have to use log base 10, you could go log base e or an ln. But you could do any base you wanted. So you could do log base 3 of m over log base 3 of a. You know, it's not going to matter. Just use the one that's most convenient. Okay, so example 1. So we're going to get practice with these properties here. And before I forget, the thing about the properties is that they work forwards and backwards. So you can take this, turn it into multiplication, or you can take the multiplication and split it into addition. So these we're going to combine into a single logarithm. So we're working, it's like we have this expression, we're trying to get to that one. So we're just going to follow the properties along. So the subtraction means I can turn it straight into division. And you always want to simplify down as far as you can go. So 16 over 2 is just 8. Uh-oh, well, now the base matches this number, so that's property number 5. So they all cancel out except for the exponent, which is a 1. So that equals 1. And yes, you have to take it that far. If you stop early, if you just stop here or here, you will get it marked wrong. Okay, this one, we can't multiply them together yet because you have a coefficient. The property doesn't have coefficients in front of the log. So if there is one, you got to use property number 3. You got to pull that exponent up before you can start multiplying them together. So if you pull that up, that'd be 2 squared or 4. And now you can multiply them together. So 16 times 4 is 64, but this is going to simplify down. Either using property number 5 or doing what we did in the previous section. What exponent can you put on the 8 to make it a 64? A 2. All right, now let's try them with just variables. So whether they're numbers, variables, the properties do not change. So that's going to be log base 5 of x over y. That's all you can do. All right, this one, we got to move your coefficients up into be exponents. So that'll be log base 5 of x to the 4th minus log base 5 of y squared plus log base 5 of z to the 1/2. And now we can use properties number 1 and 2 to combine them into a single logarithm. And when we have multiple logs like this, like more than 2 of them, anything with a positive in front of it gets multiplied together on top. Anything with a negative in front of it gets thrown into the denominator. So that's going to be log base 5. The x to the 4th is on top, as well as z to the 1/2, which is just root z. And then over, the y squared is going to go in the denominator. So just like that. Okay, now property number E, we have different logs, or sorry, different bases. So the properties aren't really going to apply except for one of them. And that one property is the 7th one, the change of base. Because look what happens when we change them to the same base. And personally, I like to go with this one, the log, or the natural log, the ln. If you want to use log base 10, that's totally fine. But I like the ln. So that's going to be ln of 7 over ln of 4 times ln of 64 all over ln of 7. And we can definitely keep going because the ln of 7s would cancel. So you end up with this. But we can keep going again because you have to be careful when you have something like this, because 64, that's a power of 4. So that's going to be 4 to the 3rd. And using that third property, we can pull this exponent down. And now the ln of 4's cancel out and we just get 3. And yes, you do have to simplify it down that far. So you really got to know your exponents, and you really have to know your properties in order to be able to simplify it as far as it can go. Okay, I'm going to keep going because this one page is the entire section, so let's just go ahead and get it done. So now example 2, we're going to go backwards. So we're going to write this one logarithm just like this, as a sum or difference of logs with no products, quotients, or powers if applicable. Okay, so what we can do is everything on the top would get its own logarithm. So that z to the 3rd is going to get its own. The square root of z, or sorry, the square root of x gets its own. And everything in the denominator gets its own logarithm too. So log base 5 of w squared minus log base 5 of y. So everything that was in the denominator gets a minus sign in front of it. And we don't want any powers, so with these we can pull each power down. Oops, I forgot the square root. So that would be 3 log base 5 of z plus 1/2 log base 5 of x minus 2 log base 5 of w. And then the y, there's nothing to move, so it just stays as is. And some of you are going to get really good at these. If you're not already there, like you can look at this and jump straight to your answer. Like you can split it all apart, you can pull all your exponents down all in one step, and that's totally fine. Others, you're going to have to write it out like that and then pull all your exponents down. So it just depends on your comfort level. Okay, so let's try the same thing with this. So it's going to be log 5, 25. And let's try to split and move powers down. So this x squared, the square is going to come down to the front. And then that quantity that's in the denominator gets its own logarithm as well. Well, we can keep going with this because that log base 5 of 25, 5 to the what is 25? Well, that's just 2. This next term doesn't do anything, but this one does because x squared minus 1, that factors. And the x minus 1, x plus 1. Well, now you have another product, so we got to split it. And whatever you split it into, still that entire thing still has that minus in front. Forgot to split. And now you can distribute your negative across. And we're finally there. All right, so that is going to do it for the properties of the logs. So try the homework out and let me know if you have any questions.